In this video, we'll generate the DeMoivre cosine function using IMPOWER, IMREAL, complex factorial, cosine, sine, and the Taylor series expansion. We begin with the values of f. So data validation, list of items, 0.4 to 1.575. We can start with 0.4. We continue with the first, which is the summation of a times x to the power n, where n starts from 0 to infinity, if it is good enough. And the value of a is cosine n pi f over factorial n. So this will be array formula. Cosine n pi f times f. That's the numerator. Divided by our denominator is factorial n, factorial of n. Now we can continue with the first expansion. So array formula, series of the x values raised to the power n, where n starts from 0, incremental by 1. And the coefficient a will be this range. And we can complete the expansion, which is the summation b times x to the power n plus 1, where b is, we begin with the complex number. So this is the complex number raised to the power n. So array formula, complex. The first part is cosine pi f. So cosine pi times f. That's plus I sine pi f, so comma, sine pi times f, and enter. So the first one is cosine pi f, so we close this, and sine pi f. And this is raised to the power n. So IMPOWER, comma, raised to the power n. And we're interested in the, so it's raised to the power n, we want the real part, so this will be IMREAL. And we divide this by factorial n. That's our denominator. So we have completed the numerator, now denominator, factorial of n. Their values are exactly the same. Now we can complete the expansion, array formula, that series sum. So series sum of the x values raised to the power n, where n starts from 0, incremental by 1. And the coefficient a, b will be this range. And we'll chart this. Insert chart. And we use scatter chart. Column is labeled. We don't need a title. And we show the trend line under series, the trend line, the type polynomial, the degree 6. For the label, use the equation. So here's our trend line and polynomial of the DeMoivre's cosine. We'll try changing the values of f to 0.5. This is the value of f. This is now, the blue one is a steady state sine, cosine. We also change the value of f for the second expansion to 0.5. Now they're the same. So it's a steady state cosine. Change this to 0.6. Now it's a decaying cosine. Change this also to 0.6. It's also a decaying cosine. Change this to 1.425. Still a decaying cosine. 1.425. Also a decaying cosine. Change the first one to 1.5. Now it's a steady state cosine. And we can also change this to 1.5. Now they're the same. Steady state cosine. Then we change this to 1.575. So we have an increasing cosine. Change this also to 1.575. Increasing cosine. So this completes the use of the series sum function to generate the Taylor series expansion of DeMoivre's cosine in two forms. This form, the cosine and the complex.